Find all zeros in a complete factorization of p of x equals x to the fourth minus 81. This is actually a difference of squares. X to the fourth is x squared squared, and 81 is 9 squared. So we can rewrite this as x squared plus 9 times x squared minus 9. And we recognize that x squared minus 9 is a difference of squares, so that can be broken down even further into x plus 3 times x minus 3. Now this might look like a complete factorization, but it's not, because this first one will factor even further now that we're able to deal with complex numbers. But first, I want to find the zeros, because I think that will help with the factorization. We know that x minus 3 gives us a 0 of 3, and x plus 3 gives us a 0 of negative 3. To find the zeros that we get from x squared plus 9, we can set it equal to 0 and solve. If we subtract 9 from both sides, this gives us x squared equals negative 9. And applying the square root property, we get x equals plus or minus, what's the square root of negative 9? 3i. Remember that when we take the square root of a negative, we end up with an I. So the four zeros, if we wanted to write them as a comma-separated list, are going to be positive 3, negative 3, positive 3i, and negative 3i. Now we know that 3 and negative 3 correspond with the factors x minus 3 and x plus 3, but 3i and negative 3i are also going to correspond to their own factors. So we've got x minus 3 and x plus 3 from the first two zeros, and then for 3i as a 0, this corresponds to the factor x minus 3i. And for negative 3i, this corresponds to x plus 3i. And so we have our zeros and our complete factorization. In general, when we have a sum of two squares, like x squared plus 9, we can break it down very similarly, but instead of x plus 3 and x minus 3, it'll be x plus 3i and x minus 3i.